The Toratrac full toroidal variator. The full toroidal variator is the core of Toratrac's technology. This animation will show how a typical variator is constructed and works, based upon a twin-cavity, 6-roller configuration. The variator is built around a shaft, which is driven by a power source, for instance an engine or motor. 2 input discs are fixed on the shaft, one at each end of the variator. A double-sided output disc is supported on a bearing at the centre of the shaft, so that it is free to rotate about the shaft, but in the opposite direction. The output disc drives a load, such as the road wheels of a car or a supercharger. The rollers are positioned in the toroidal cavities formed between each pair of opposing discs. In this case, there are 3 rollers in each cavity. As the variator components rotate, power is transmitted from the input discs to the output disc via the rollers. The angle of the rollers changes with the variator ratio and relates to the speed difference between the input and output discs. Torque, or drive, is transmitted through the contact points formed between the rotating discs and rollers by a specially formulated oil known as traction fluid. The rotating rollers and discs are forced together, trapping the fluid at the contact points. The resulting high contact pressure makes the fluid thick or viscous, enabling torque to be transmitted without physical contact between the rotating surfaces. A hydraulic cylinder, or end-load drum, containing one of the input discs, is positioned at one end of the variator. Hydraulic pressure in this drum forces the discs and rollers together, creating the required contact pressure. Traction fluid is introduced under pressure into this cylinder, generating the required end load. The rollers are supported within a mechanism which controls their position as they move within the toroidal cavities. Each roller runs on an axle, mounted on bearings, located in the roller carriage, which in turn is connected to a lever, which pivots around a fulcrum. Control forces are applied to the roller mechanism by the control system, in this case a hydraulic reaction piston. All of the reaction pistons are contained in a single hydraulic control block, positioned below the variator. Equal proportions of drive power are transmitted by each roller in response to a common control input. The complete variator unit provides a power-dense, scalable, variable drive system capable of application across a broad range of products and markets.